All right, good morning or afternoon, whenever you're watching this. So we are in week 9, statistics, lesson 19.2, permutations and probability. So we're introducing something a little bit new. You are going to be doing probability like you did last week in order to find the chance of something happening. However, we're going to include something called permutations, and you're going to use factorials in order to find these permutations. So the vocabulary I have is right there. Permutation is a selection of objects from a group in which order is important. Factorial is a method for finding permutations where n exclamation point, where n is a number, and exclamation point just means that you're going to have to multiply all the numbers that come before the number that's listed. I'll go into more detail with that in a bit. And again, the probability is just a chance of an event occurring. It's usually going to take a form of a fraction, and the fractions are going to be just the numerator is always going to be what the event that you want to happen divided by the total possibilities of that event happening. It's very similar to what we did last week. So hopefully it's not too much, but let's get into it. So here, in order, a regular permutation problem solved by a factorial. That's what we're doing here. So what I mean by that is, if you read what the problem says, for example, the problem says there are 7 members of a club, right? So there's 7 people, right? Each year, the club elects a president, vice president, and a treasurer. What is the number of permutations of all 7 members? Okay, so when here they're just asking for permutations. So a way of thinking about permutations is the different possibilities of that event happening. It's not quite that, but you'll see what I mean when we get into the math. So what is the problem asking you here? The problem is asking you to find different ways that each member can be arranged, and you need to use a regular factorial to find all the possibilities. What I mean by that is, if you take a look at, don't look at the end exclamation point, look where underneath where it says members. Notice how I have A, B, C, D, E, F, G. That's 7 letters. Each one of those letters represents a person, right? We wanted to find out the different possibilities of arranging these people in a specific order, right? We could have the original A, B, C, D, E, F, G. That's one way of doing it. That's one permutation. A different variation of that would be, what if B is first and we keep going in that order, right? B, C, D, E, F, G, A. Right? So if you notice they're in order right here, and I'm just kind of pushing the next letter over. That's the second possibility. The third will be if C's first. The fourth would be if D's first, E's first, right? And this is all different possibilities. However, the thing about factorials is that they're referring to the entire possibility, which means I don't care about order. I don't care about repetition, right? A letter can be in the same position over and over. So even though you might not think that there's a lot of possibilities, there's actually a lot more than you can consider, because A can be in any one of those positions, and it can be in any one of those positions multiple times. So there's all different possible possibilities. So instead of just sitting here and writing all the different possible combinations down by hand, which would take absolutely forever, we're just going to solve this mathematically. So if you notice, we have the n with the exclamation point, right? This is what we call a factorial right here. Whenever you see an exclamation point next to a number, that's referring to all the numbers that came before it. So here there are 7 members. So we put n becomes 7. That's why I have 7 factorial here, right? And the exclamation point in this case is not an exclamation point, it's a factorial, and I'll be calling it a factorial. So 7 factorial is the same as saying 7 times 6 times 5 times 4 times 3 times 2 times 1. Do you really need that 1 there? Mathematically, it doesn't make too much of a difference, but we like to put it in there because we want to emphasize the point that if you're just solving a factorial, that's all you're doing and nothing else, you're starting from whatever number they tell you, and you're multiplying it by every number beneath it, right? So 7 factorial is the same as 5,040. That means if you were to multiply 7, right, times all the predecessor numbers, you end up with 5,040 different ways of arranging those group numbers. And that's really what I'm looking for, okay? So that's just the basic factorial. That's just what a factorial is and how to find it, right? what you're going to be asked to do is a little bit different. You're going to be asked to find factorials in context of the real world, right? So what that means is, what if three positions, like for example, on the bottom right, it's a variation on this problem that I just answered. So what if three positions, what if the three positions, in how many ways the three positions can be filled? Remember, you're trying to find a president, a vice president, and a treasurer. That's three different positions, and there are 7 people. So what are the different possibilities of the different combinations of people, right? That can be either of those things. Well, you got to think of it like this. In order for you to pick a president, you have 7 potential people in the club that could be a president, right? So that's 7 possibilities. That's why I wrote president, right? And I have 7 right there, right? I'm going to multiply that by, all right, so let's say we pick a president. Let's say we pick one person. Now, all of a sudden, if we want to pick a vice president, that one person that's now president can't be a vice president also. So they're no longer in there, right? There's now a pool of 6 people that can, and of them, one of them can be chosen to be vice president. So that's 6 possibilities, which is why for vice president, there's 6 possibilities right there. However, once we picked our president and vice president, now we only have 5 people. Of those 5 people, one of those people can be a treasurer, right? So there's 5 possibilities for treasurer. If you want to find out the 3 different ways, if you want to find out how many different ways these 3 positions can be filled with different people, we multiply 7 times 6 times 5, and that gives us 210 different ways. Now, if you notice, here we have, it's different because we have, instead of having the entire total permutations, all possible possibilities, right? We figured out that there's only 210 different ways of arranging the 3 positions by people, right? Because once they're taken out, we can't reuse them. So that's a different kind of problem, right? So there's a difference between just finding a regular factorial versus trying to find out how many different ways something can happen. Okay. Okay. So with that in mind, let's move on to finding the probability using permutations. Now, I'm going to introduce a formula here. The formula for the probability of permutations. This is what you're going to be using to find that formula, right? Now, if we remember from last week, probability is defined by just having the event that you want to happen divided by the total possibility of that event happening. You're still going to do that at the end. But in order for you to figure out what is possible and what is not possible, you're going to need to use this formula that I have here, right? It says NPR is equal to n factorial divided by parentheses n minus r factorial on the outside of the parentheses, where n is the total possibilities and r is the number of the desired group. You're going to use this twice to find out 2 different pieces of information. So what do I mean by that? Let's go into the example, right? The example problem says, a research laboratory requires 4-digit code to gain access to the facility. A security code can contain any digits from 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9, but no digit is repeated. Now, this part right here is really important. The fact that they said that no digit is repeated, meaning that we have to use this formula, and we're going to only use this formula, right? If they allow the digits to be repeated, we'd have to use a different formula, which we're going to do later. So here, we're just focused on this. The key part of this problem is no digit can be repeated. If you already have a 1 in that code, you can't have another 1 in that 4-digit code anymore, right? So that seriously reduces the number of possibilities and permutations, right? So what is the probability that scientists is randomly assigned a code with digits 1, 2, 3, and 4? Okay, so now we have to determine what our n and our r is, right? So in this case, our n is there's a total, what's the total number of digits that we're gonna choose from? Well, there's 10 digits because we have 0 and we go 1 through 9, so that's 10. So our n is equal to 10. Our R is the number of groups at a time. They're asking what is the probability that we're going to be assigned a code that has digits 1, 2, 3, and 4. There's 4 digits in that code. That means that the group is made up of 4 digits. So R is equal to 4. So now we're going to go into what I have down there, right? We have NPR is equal to n factorial divided by parentheses n minus r, close parentheses, and the factorial outside of it. Now this factorial outside of it is key, right? If we're trying to just find the total permutations possible, right? All the possibilities, right? We're gonna start with 10 factorial divided by n minus r. Since n is 10 and r is 4, we're going to take 10 minus 4 inside the parentheses. And we're going to leave the factorial on the outside. The factorial on the outside only matters for whatever after we subtract, right? So when we subtract 10 minus 4, we're going to get 6. So we have 10 factorial divided by 6 factorial. Now, as is shown in the previous problem, right? This previous section, we have a factorial. It's all the numbers that are before it. I didn't have enough room, so I didn't write it in there. But just know that 10 factorial is 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. That's how I got the number on top. And I divided that number by 6 factorial, which is 6 times 5 times 4 times 3 times 2 times 1. You can just put this in your calculator, right? Because that's a lot of numbers to be typing in. If you have the factorial function on your calculator, you would put this in your calculator as follows, right? So let's see if we can do this. You put 10 factorial, then you put the division sign, then you put 6 factorial, and it should give you 5,040 permutations possible, right? Because what ended up happening here is the 6 factorial, 6 times 5 times 4 times 3 times 2 times 1, canceled out with the 6 times 5 times 4 times 3 times 1 of the numerator. And what's left over is just 10 times 9 times 8 times 7, and that's it. That's all that's left over of the 10 factorial. When you multiply those numbers, we get 5,040, right? So I'll go into more detail with that later if you guys are still confused about that. There's just a shortcut. I would encourage you to use your calculators at this point because it's more of the concept of the possibilities that I'm interested in, not necessarily if you can write a permutation out by hand. Okay, so now we need to find out, that's our denominator. That's our total possible permutations in my probability, right? And now I need to find out the numerator of my probability. I need to find out what is the chance of being randomly assigned a code with digits 1, 2, 3, and 4, right? So I started with the same formula, n factorial n minus r, except however, in this case, we're only using the group of 4. So the total number of numbers that I'm allowed to pick from, I'm only allowed to pick from numbers 1, 2, 3, and 4 in this example. And, right, the number of numbers in this group happens to be 4 numbers, which is why you see the factorial below. We're right here, right? We have 4 possibilities, right? So 4 factorial divided by n, which is, again, 4 minus 4, which is the number of groups. They just happen to be the same number. That's not always going to be the case, but they just happen to be the same number here. So then we have a really weird situation, right? We have 4 factorial divided by 0 factorial. This isn't a normal situation. In a normal situation, you wouldn't be able to divide by 0, right? However, here, that's not really what we're doing, right? This is a factorial, and factorials don't necessarily have the same rules as regular fractions, right? Here, what I'm really saying, right, is I want to find the possibilities of 4 times 3 times 2 times 1 divided by 0 factorial, and 0 factorial just means nothing, right? So we're not actually dividing by 0. We're not actually dividing at all. There's just nothing there. So we end up having to just, basically this boils down to 4 factorial. 4 times 3 times 2 times 1, which means that there's 24 possibilities in the desired group. Okay, so how do I find the probability, right? I have 24, I have 5,040, what am I gonna do? Well, we've established that 24 is my numerator in the probability, it's event A, and the total probability is 5,040, so that's my denominator. So I'm just gonna divide them, right? So I'm gonna divide 24, which is what I wanna know. There's 24 possibilities of getting a code with digits 1, 2, 3, 3, and 4, and you're gonna divide that by the total possibilities, which is 5,040. 24 divided by 5,040 reduces to 1 out of 210. There's a 1 out of 210 chance of a scientist getting a code with the numbers 1, 2, 3, and 4 in any order, right? In any order, and the numbers are not repeated. Right? That's a very specific probability, right? Okay, so take a break if you guys need to. There's still one more possibility, right? There's still one more thing I need you guys to do. And it's a version of this, just slightly different. This one, remember how I said is the digits are, no digit is repeated, right? Well, what happens if they do want you to repeat? Well, if they want you to repeat, you're going to end up with way more possibilities than you did if you're not allowed to repeat. So the formula has to change a little bit, all right? So last thing, find the number of permutations with repetition. The formula to find the number of permutations with repetitions is n factorial divided by r factorial times s factorial times t factorial. And this kind of goes on forever. I stop at 3, right? R, S, T don't represent different things. Well, they do, but they just represent the groups, right? What I mean by that is when something is repeated, we need to know how many times it was repeated. So N is the total possibilities, RST is just the different groups that we're taking into account, right? So in the example problem, right, we have a school jazz band has 4 boys and 4 girls. Those are my groups, all right? They already tell me straight up, those are my groups. 4 boys, 4 girls, right? They are randomly lined up for yearbook photos. Find the probability of getting a boy-girl arrangement, right? We want to know what is the chance of arranging them, right, in between boys and girls. So what that means is we're going to use the formula that we just learned, the n factorial divided by the other groups. So in this case, right, we have the total number, the n, happens to be 8 because there's a total of 8 students, right? And the students are broken down into groups between gender, between boys and girls. There's 2 different groups, right? So 8 factorial would be on top, and we divide that by 4 factorial because that's the probability of getting boys, right? And multiply that by the probability of the number of girls in this group, right? Which is also happens to be 4 factorial. If there was 3 girls instead, it would be 3 factorial, right? If there was 12 girls instead of 4, it would be 12 factorial. Those numbers just correspond to different groups. Okay, so here, what this means is, again, you can calculate this on the calculator by just putting this whole thing in there, and I'll show you how to do that below. However, what's actually going on paper is this. 8 factorial is the same as saying 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And you're going to divide that by 4 factorial, which is 4 times 3 times 2 times 1, times another 4 factorial, which is another 4, 3, 2, and 1. So if you notice, that's what I have here, right? This is just the factorial expanded, right? That's all I did. I just expanded it to include all the numbers so I can clearly see what I'm dealing with. Now, if you notice, we do have a rule here. This is a fraction, kind of, and if I have the same number on the top as well as on the bottom of a fraction, I'm allowed to cancel them out, right? So here, I'm going to cancel out the 4, the 3, the 2, and the 1. I can't cancel the other 4, 3, 2, and the 1 in the denominator because there's no other 4, 3, 2, and 1 in the numerator. So really what I'm left with is just 8 times 7 times 6 times 5, right? Divided by 4 times 3 times 2 times 1. That is really what I'm saying. When that whole formula just boils down to these numbers multiplying, and that's it. That leaves me to 1,680 divided by 24, which gives me 70, right? So here, what is the probability of getting a boy-girl arrangement, right? So here, if I'm trying to do this in a calculator, right, I'm gonna have 8 factorial, and I'm gonna divide that by 4 factorial times 4 factorial. Make sure to put the parentheses, otherwise it won't work. You're gonna get this crazy permutation if you do. So there's that. Okay, so with that in mind, the rest of the problem it's just asking for the probability. Now, if you remember the probability here, right? The probability of getting all boys grouped together, right, is going to be, you're going to have to find out the different fractions again, right? So the probability of getting all the boys grouped together, right, is the probability of the number of boys, right, divided by the total. What we just found out right here is total permutations. Okay. So this is the total possible permutations, right? That's what we just figured out. So depending on what they're asking us, we could do a couple different things, right? So let's say we were trying to find the probability of getting a boy and girl alternate arrangement, right? So what is the chances of getting a boy-girl alternate arrangement, right? So we need to find out what is the possibility of a boy-girl order. Well, the truth is, in order to get a boy-girl combination, right, there's only two different ways of doing that, right? You can get a boy first and a girl, or you can get a girl and then a boy. That's two possibilities. So my probability, right, of finding a boy-girl arrangement is going to be 2 divided by 70, or it's going to be a 1 out of 35 chance. Now, the reason why it's 1 out of 35 and not just like 50% or whatever, it would be because you're asking for a specific boy and a specific girl to be grouped together. That's really what this is kind of asking you. Like, what is the probability of getting a very specific boy from the boys group paired up with a specific girl in the girl group, right? And then take the picture together. Well, if we have a total of 8 students, 4 boys and 4 girls, using all the possibilities, there's a 1 in 35 chance that a specific boy will be paired with a specific girl. Now, if you're wondering how I got the 2, right, we could use another permutation, right, to solve this for this, right? Really, it just kind of depends on how many, right? So in this case, sorry, I'm looking at the thing right now. In this case, it was really just about understanding what is the possibilities of, or what they want, right? If they instead said something like, what is the probability of all 4 of the boys uh, being in one picture together or something, then the number would change. But for now, that's really all we're doing. So again, hopefully that was clear. I'm not sure if that was too clear or not. There was a lot in here. Please stop by for office hours. The problems that I want you guys to do for the homework and practice are 1 through 3 are going to be factorial problems. All you have to do is put the factorials. 4 through 7 is probability, no repetition, kind of like the first problem we did. And 8 through 10 are kind of like the problem with repetition, are the ones that we just did. So make sure to look over those examples and do your best, okay? If you get confused, join me for office hours, 1:30 to 3. Send me an email or any other way of contacting me. I'll help you guys out, all right? So this is all due by Sunday, and yeah, that's it. Good luck.